Explain the lattice energy. Today I am going to explain the lattice energy. If you like this video, please subscribe my channel. See what is the lattice energy? Lattice energy means the amount of energy is released when opposite charged gases ion come close together to form a one mole of crystal. It is exothermic reaction. What is the lattice energy? The amount of energy released when opposite charge means suppose Na plus gases ion combine with the chlorine ion. It is in gases. They combine together. They combine together to form a one mole of crystal, one mole of solid. At the time, some energy is released. At the time, some energy is released. Is known as exothermic crystal lattice energy. Lattice energy. What is the lattice energy? What is the lattice energy? The opposite charged gases ion. The opposite charged gases ions like positive sodium gas and chlorine negative gas is combined together to form a one mole of crystal. This is the one mole. How many? One mole crystal is formed. One mole NaCl crystal is formed. One mole NaCl crystal is formed. It is a solid. NaCl is means gases ion combined to form a one mole of crystals. At the time, some energy is released. That is known as exothermic. That is exothermic and also lattice energy. Means this is the sodium ion plus this is the Cl minus. Both are combined together. What happened? Sound is released. Like this, both are combined. They release an energy. They form. This is the one mole of crystal is formed and release the energy. That is known as lattice energy. Lattice energy directly proportional to charge. The lattice energy directly proportional to charge of the ion and size of the ion. Means lattice energy is increased, charge increases, size is decreases. Okay. And coming to third point, lattice energy increase boiling point, melting point, stability, thermal stability. Lattice energy increase, boiling point, melting point, thermal stability increase, and lattice energy is increases. Lattice energy is increase, solubility decrease. Solubility decrease means lattice energy increase, melting point, boiling point, solubility increase. Lattice energy increases, stability increases. Lattice energy increases, solubility decreases. And lattice energy is more. Lattice energy is more for ionic crystals, ionic compound. Then covalent. Okay. Next. Lattice energy increases. Metallic characters increases. Metallic characters increases. Why means size is increases. Atomic radius is increases. Radius increases. And the boiling point BP and MP of metallic compound is increases. And lattice energy lattice energy decrease. Which character decrease? Non-metallic character. Non-metallic character. Character. Non-metallic character increases. Means atomic radius decreases. Atomic radius decrease. That's why boiling point and melting point is decrease. Dp and Mp is decrease. Okay. What is this? Lattice energy increases. Metallic character increase, and due to atomic radius increases. Boiling point and melting point also increase. Lattice energy decrease. Non-metallic character is increase. Atomic radius decreases. Boiling and melting point is decreases. Okay. And univalent, suppose univalent and univalent. Okay, univalent and univalent. Next, univalent and bivalent. Bivalent. Okay, means what is the meaning here? NaCl, MgCl2, and MgO. Means NaCl is a plus, it is a plus 2, it is a plus 2, minus 2. Here it is a minus 1, here it is a minus 1. So which is the lattice energy? More lattice energy, this one. More lattice energy. Means this is the lattice energy. Lattice energy increases from univalent to univalent, and univalent to bivalent, and bivalent to bivalent. Here see, among Na2 CO3, okay, and Mg CO3. Which is more soluble in water? Because see, it is a charge. What is the charge? Plus charge. What is the charge? Plus 2 charge. Charge increases, lattice energy increases. Means it has more lattice energy, and solubility low soluble. Okay, means Na2CO3 is a plus charge. Charge decreases, lattice energy increases. Charge is more, so charge is decreases, plus charge, so lattice energy also decreases. Means here low lattice energy. So low lattice energy inversely proportional. No? Low lattice energy is inversely proportional. Lattice energy solubility is depending on lattice energy and hydration energy. Solubility is depending on important point. Solubility T inversely proportional, directly proportional to hydration energy, and inversely proportional by lattice energy. That is very, very important. What is that? Solubility is directly proportional to hydration energy and inversely proportional to lattice energy. Means solubility is lattice energy increases, solubility decreases, but hydration energy increases, solubility increases. What is hydration energy? The amount of energy is released when the hydrators are elements are soluble in water. Okay, so low lattice energy means more solubility, more solubility, more soluble. Okay, more solubility. And if you see same cation, same cation, but anion differ. Same cation but anion is differ. What happened? Like example, same cation CaF2 CaI2. Same cation, cation is the same, calcium calcium, but anion is differ, fluorine and iodine, which is high melting point. And high melting point means same cation. What is this? Same cation but different anion. Anion size is small, that is an ionic compound. Ionic compound has the highest lattice energy. So it is a small anion, it is a big anion. Small anion have ionic compounds, means it is an ionic. It is ionic. Ionic have more lattice energy and low solubility. Coming to this, CaF2 is a big anion. Big anion means covalent. Covalent means low lattice energy. Low lattice energy means more solubility. Okay. Okay. Means same cations, but anions are different. Small anion is ionic, big anion is a covalent. Ionic character increases, lattice energy increases, solubility decreases. Covalent character increases, lattice energy decreases, and solubility increases. Okay. And last one, same anion but differ cation. But differ cations. Like example I taken LiF and Li iodine. LiF and Li, which is means same, so same anion but different cation. You know? Same anion but different cation. CsF. Okay. Same anion. Anion is same. Anion is same but different cation. Here cation is small cation is a big cation. Small cation is a covalent. Small cation is a covalent. Covalent. You can see my video. What is the ionic character and what is the covalent? Means small cation. Covalent means small cation, big anion is required. Ionic means big cation, small anion is required. So it is a cation, anion is a constant in both cases, but cation is small. Cation is a small means that is a covalent. Covalent means low melting point. Low melting point. Okay. And high soluble. Here CSF. CSF means is a covalent. Okay. And CCM is a big size, means high melting point. Okay, and high melting point means low solubility. Okay, this is the lattice energy.